What if the biggest shift in AI isn't smarter models, but how we scale them? Most people are still thinking in terms of single prompts, but the real future, it's agents. And they change everything about how we build in AI. In this video, we're diving into what it actually means to scale in the agentic era, where AI systems don't just respond, they plan, act, and collaborate across tools, data, and even other agents. I'll break down the key challenges companies are already running into, the architectural shifts you need to understand, and what separates systems that look impressive from ones that actually work in production. If you're building with AI or planning to, this is the mental model you need to stay ahead. Let's get into the details right now.
Today, we're diving into a really big shift in AI, and this is coming straight from Google Cloud. See, they're not just thinking about the next step in AI infrastructure, they're actively building it for something they're calling the Agentic era. So let's break down exactly what that means.
I mean, think about it for a second. What if AI could go way beyond just answering our questions and actually start doing things for us? That one simple question is what's driving this next massive leap forward in artificial intelligence. We're stepping into what Google is calling the agentic era. This is a huge change, right? We're moving away from just asking an AI for a piece of information to giving it a goal and just letting it take action. Here's a way to picture it. Instead of having one single do-it-all assistant, imagine you have an entire team of specialized AI agents. You give them a single goal, and they work together. They collaborate, they reason, and they take real action to get you the outcome you wanted. Okay, so that sounds amazing, right? But trying to manage a whole team of AI agents like that creates this massive technical problem. The infrastructure we have today, well, it just wasn't built for this level of complexity. Not even close. Yeah, when you try to build these agentic systems on older tech, you run into some serious roadblocks. You get tangled up in this web of complexity, your costs just spiral out of control, performance hits a wall, and you're stuck trying to glue all these fragmented pieces together. It's not going to work long term. But what if you didn't have to patch everything together? What if there was a system that was designed from the ground up, specifically for this new era? And that's exactly where Google's solution comes in, the AI hypercomputer. Now, this isn't just a box of powerful parts. It's a single, unified system, purpose-built from the ground up for the insane demands of agentic AI. The key phrase here is co-designed. It means every single layer, from the silicon all the way up to the software, is built to work together perfectly. And this isn't some experiment. It's the exact same foundation that powers Google's own heavy hitters like Gemini. So how does this whole thing work? Well, the entire system is built on 4 core pillars that make all that performance possible. The system basically stands on 4 legs. You've got massive compute power, super fast networking to link it all together, bottleneck-free storage to feed it, and really smart orchestration to manage the whole show. Let's start with compute. Google has 2 new specialized chips. On one hand, the TPU-8 is an absolute powerhouse for training, cutting down training times from months to just weeks. On the other, the TPU-8i is a reasoning system, built for the crazy low latency you need for real-time AI responses. It's designed to smash through the memory wall. That's a classic bottleneck where your super-fast processor is just sitting around waiting for data. And the scale here is it's hard to even wrap your head around. Google can connect over 1 million of these TPU chips together to create one single gigantic training cluster. But it's not just a TPU show, and this is really important. For flexibility, the AI hypercomputer also fully supports the latest gear from NVIDIA, plus high-performance CPUs from Axion, Intel, and AMD. It's all about having the right tool for the right job. So, you've got all this amazing compute power. How do you connect it all? That's where the Virgo network comes in. It basically transforms all of Google's globally distributed data centers so they act like one single seamless supercomputer. The capacity is just immense. The Virgo network can tie together up to 960,000 GPUs across different locations. This basically gets rid of the scaling tax. That performance hit you normally get when you add more and more hardware. It lets these AI workloads scale with almost perfect efficiency. All right, next up, storage. To make sure all that powerful hardware is constantly fed with data, Google rolled out 4 major upgrades. They cranked up training bandwidth, slashed latency by sending data straight to the chips, and made sure those expensive processors are always working, not just waiting around. And finally, the conductor of the orchestra. Just look at these numbers for Google Kubernetes Engine, or GKE. Node startup is up to 4 times faster, models load 5 times faster, and this is the big one, the time it takes for an AI agent to even start responding is down by over 70%. That's the difference between a clunky, frustrating experience and one that feels instant. So we've looked under the hood at all this amazing tech, but what does it all really mean in the real world? What's the payoff for the people who are actually building and using this stuff every day? I think this quote from Google Cloud's leadership just hits the nail on the head. Because they've co-designed the whole thing, top to bottom, they get to remove all that painful integration work. That frees up your teams to focus on what they should be doing, building cool stuff and solving real problems. So the bottom line is this. A unified system like this means you can innovate faster, you can build incredible user experiences, and you can do it all more efficiently. You get to focus on creating business value, not on messing with the plumbing, because the whole integrated stack just handles the complexity for you. And really, that brings us to the final, most exciting question. With all these bottlenecks just gone, and with the power of what is basically a single, unified supercomputer at your fingertips, what will you build next? The possibilities are really just starting to open up.